Hey guys, welcome back to the channel Techbeast.org. So this is the final part 3 of our short LoRaWAN course. Okay, so in this video, what I'm going to show you is we are going to set up our own LoRaWAN gateway from the scratch, and I'm going to use Kerlink. So Kerlink is one of the LoRa gateway uh, manufacturer, and we can say producer. We are just going to use this gateway for this short course, and we are going to configure this gateway from the scratch. We are going to set up the LoRa packet forwarder IP addresses, and we are gonna forward all the sensor packets to our LNS, which we just configured in our previous video. So if you have missed to watch how to set up a LoRaWAN server using Chipstack in AWS, just go ahead, check out the part 2 of the video, which is in the description. And if you want to know what is LoRa, how LoRaWAN works, you can just check part 1 of the video, which is also in the description. And you can come back here to set up the Kerlink's LoRaWAN gateway. Okay, so let's get into the course. So here we are going to use the Kerlink's wirenet ifemto cell evolution gateway. So that by basically this is just a model of the gateway. So it's not just big name. Don't get confused. It's just a wirenet ifemto cell evolution model. So it's basically an indoor LoRaWAN gateway, and it looks very compact. Okay, so it's easy to set up and configure, and we have a backhaul connectivity over Ethernet and GSM. So here today in this course, I'm gonna use this backhaul connectivity over Ethernet. Okay, so if you have a SIM card, you can just insert it and you can connect to LNS over mobile network. So this gateway provides a web access and shell access. So basically, it's easy to update the gateway using web access. If you want to configure this LoRa forwarder and other setup, if you want to connect some VPN and all these kind of setups, you can use this shell access. It's really helpful. Okay, so now I just assume that you have this gateway and you have connected this gateway to your home router. Okay, so basically connecting the gateway to your home router to get the IP address of the gateway over DHCP. So your home router will automatically assign an IP address to this gateway, and from there our configuration part begins. Okay, this is the network setup of our LoRa gateway. So this is the ifemto Kerlink's ifemto evolution gateway, which has an Ethernet backhaul over the Ethernet. I have connected the Ethernet, the gateway to my router, one of the Ethernet port in my router, and another port is just a WAN network to connect it to the internet. Okay, so then the IP address of my gateway is 10.10.90.115. So this is the IP address I'm gonna use throughout this video, and you can just note it down. Okay. Yeah, so let's get into the topic. And to learn things, getting your hands dirty is the best way to learn things. So let's configure the gateway.
Configure the ifemto gateway. So the first step is you just need to connect the gateway to your home router, and the gateway is already configured with the DHCP enabled option. So automatically your home router will assign an IP address for your gateway. Okay, so you just need to log into your router and find the IP address of your gateway. So in my case, my ifemto gateway has an IP of 10.10.90.115. Okay, so you just go to your browser and type. It will take you to a web page. So now what we are going to do is we are going to configure this gateway. We are going to install the latest firmware, and we are going to configure the LoRa packet forwarder, okay, and all the LoRa daemon and all the configurations basically needed for a LoRa gateway. So basically this is not limited to this Kerlink model. So each gateway have its own setup, but the underlying concept and logic is same. Okay, so here by default the username is admin, and I'm gonna type the default username and password, which you can refer to Kerlink's wiki page, okay, in order to configure the gateway. Okay, so now as you see, the gateway is connected over Ethernet, and you can see the IP address and all these common details. Okay, the firmware version is 4.2, which is a bit old, I think. So we have a latest firmware. So now you can see the Ethernet is on. So if you have a SIM card, you can just enable the GSM option. You can insert a SIM card. Your gateway can talk to the LNS over Ethernet internet via mobile. Okay, so in order to update the gateway, so you just click update option, and you need to drag and drop the latest firmware. So you can download the latest firmware from Wiki's Kerlink page. So if you purchase this gateway, you will get an access to all these Wiki Kerlink access, where under the resources you can download the latest firmware. So in my case, I have this latest firmware. So I'm just gonna drag and drop this uh, inside the portal. Okay, so this will just upload the file. Okay, so I think the upload is complete, and the moment it's done, you can just click update gateway. Okay, so just click update. So you can see the version is 4.3.3, which is pretty new. Okay, so Kerlink is now using a common packet forwarder, which is the latest packet forwarder which Kerlink is using for forwarding all their LoRa packets to the LNS. Okay, so this latest firmware comes with this CPF. The only thing is you need to configure your LNS, IP address, port numbers, and all these. Okay, which I will show you in a next step. Okay, so as you see the file uploaded, you now need to reboot the gateway. So let me just click reboot and just click S. Okay. Okay, that's it. So now you will lose connection to your gateway as the gateway is going to reboot. Okay, the gateway is also having SSH access which you can use and log in to configure all these configurations. Okay. Okay, so in order to log into the gateway, just type SSH root at the IP address of your gateway. Okay, so currently there is the gateway is still under reboot option, so we just need to wait for a while, and let me just ping it. And once the network is up and the gateway is up, you can see the ping messages. Okay, so let me ping my gateway 10.10.90.115. Okay, my gateway is up, I can able to ping it. Okay, so now the gateway software has been updated. Okay, so you can just log into the web page and you can check the firmware version, which is 4.3.3, and that's what we updated. Okay, so now you just need to SSH into the gateway by typing root 10.10.90.115 is the IP address, and the password you can refer to the Kerlink's wiki page. Okay, the moment you bought the gateway, so you'll be given an access to Kerlink's wiki page where you can download all the resources and all the necessary softwares with username, passwords, and all these kind of stuff. Okay, so always the first step is you just need to configure the LoRa daemon and the LoRa forwarder. Okay, so both the LoRa daemon and LoRa forwarder will be under the location /etc. Okay, so you can just list down, you can see the LoRa forwarder.toml. So this is the file where you need to configure your LNS. Okay, LNS IP address, your network server's IP address, and the port number. Okay, so before that, what you need to do is we just need to know we are configuring this gateway for which region. Okay, so since we are based in Singapore, so we just need to configure the gateway for Singapore. So in Singapore, the band is AS923. Okay, LoRa uses AS923 frequency, so we just need to change the frequency. So change directory LoRa D, and you can see that the model of the gateway is Evo evolution. Okay, ifemto. So just change to FEVO, and you can see there are a lot of frequencies: Japan, Australia, India, I think RU, Russia, US, and all these. So here we just need this AS923THSGHK-Taiwan. Okay, so just copy this, and so what we need to do is present working directories /etc LoRa D FEO. Okay, so this is the directory, and we just need to configure the path in our configuration file. So let me just go back and change directory to default location. So you can see there are two files, LoRa D and LoRa forwarder. Okay, so we just need to configure the LoRa D first. Okay, so LoRa D. So just as I said, you need to configure here. Okay, so just make sure the disable LoRa D is no, so else your LoRa daemon won't start. Okay, so just put the whole path here /etc/etc/ LoRa D /FEVO. Okay, so this is the path of our configuration file. Okay, /etc LoRa D FEVO. So the moment you verify, then you just extra args -vv. This way it will just print all the logs in detail. Okay, so just save the file. Okay, so now we need to configure the LoRa forwarder. Okay, just the similar way. So disable LoRa forwarder should be no, else your LoRa forwarder won't start, and the configuration file, as you said, it's already there /etc LoRa forward.toml. so you need to edit this file. So just save the file. Okay, so now what we need to do is just go back to one more folder, and we need to open this LoRa fwd, dot toggle file. Okay, so just type vivo LoRa fwd.toml, open it. You just need to edit. Okay, so here this is the default configuration file. So basically, you don't need to worry much about the all the configurations. So it's totally dependent on what you are going to do with the gateway. Okay, so in our case, we just need to focus on only two things. One is configuring the LNS IP address, and other one is the host. So in my case, my LoRa network server's IP address is 3.80.32.234. This is where I am running my LoRa network server. Okay, so now what we need to do is we just need to configure the uplink. So the uplink is in port number 1700, and my downlink is also in the same port. Okay, it's 1700. So just make sure this port 1700 is UDP. Okay, the port is not TCP, it's a UDP port. So all the packet forwarders will forward the LoRa packets to the gateway bridge. Okay, the Chipstack gateway bridge. So then the Chipstack gateway bridge will send the data to the LoRa network server over MQTT. Okay, so only this three you just need to configure. Then just save the file. Then restart the uh, both the LoRa forwarder and LoRa daemon. Okay, LoRa forwarder restart. Okay, successfully we have restarted. Then LoRa restart LoRa daemon. Okay, cool. So now to just need to verify, you can just type tail dash f slash where log LoRa.log. This is where the location of all the LoRa logs will be stored. So I'm just tailing it. As you can see, my messages has been acknowledged, and you can see there are some sensor devices around me, okay, which is being forwarded. So heartbeat, uplink message acknowledged. So once you get all this information, meaning your gateway is forwarding the traffic to the packet, forwarding the traffic to your LoRa network server. Okay, that's so cool, right? So now we have finished configuration of this gateway. And next step, we will add this gateway in our Chipstack LoRa network server, and we will add a sensor, and we can see how we can track the LoRa sensors data. Okay. To add the LoRa gateway to our Chipstack application server. Okay, so you just need to note down the gateway ID, which is basically the unique identifier of the gateway. So in order to know the ID of the gateway, you just need to type the command grep eui slash temp slash boardinfo.json. Okay, so this will display the EUI, the basic ID of the gateway. So in our case, it's 7076FF blah blah blah. It's a hexadecimal, so which you just need to note down. Okay, to add the gateway to the LNS. Okay, so this is the Chipstack LoRa network server. We just set it up earlier. So you just need to log in with the default username and password. Okay, and now there are no gateways, no devices, and nothing is inside. Okay, so now we are going to add a new gateway. I'm going to show you how to add a new gateway, and you can see immediately the LoRa packets being forwarded. You can manage your gateways from this Chipstack application server. Okay, so in order to forward the traffic, okay, from the gateway to the network server, you just need to add the network server here first. So the network server here, last time we just set it up in our AWS account in an AWS EC2 instance. Okay, so the network server name can be anything. In my case, I'm going to give Techbeast. So my IP address is 3.80.32.234. This is the IP address of my Ubuntu machine, so which you can just change accordingly. So then the network server is running on port 8000. Okay, so the gateway discovery, I'm not going to enable anything. I'm not going to configure any TLS certificates. So let's just leave as it is by default. Okay, the first step is always adding a network server. I have added a network server here. Okay, so now we just need to create a gateway profile. So this gateway profile means you have different types, different models of gateway. Okay, so you are going to create a profile for each model of gateway. So in my case, I'm going to create for Kerlink. Okay, so this is a Kerlink ifemto cell. This is ifemto gateway. Okay, so let me just create this. Okay, fine. Then the status interval, okay, in which the gateway reports statistics, the recommended value is 30 seconds. Okay, so let's just follow the recommended value. So
Then you see here the enabled channels, so you can just put 0 comma 1 comma 2. So by default these three channels we can just enable it, and don't just include the extra channels in the list. If you want, you can just add it here. Okay, so then choose the network server and click the create gateway profile.
So now I have created a gateway profile for my gateway. So similarly, you can have Cisco gateway, you can have your own Raspberry Pi built gateway, all your custom gateways, you can create a profile. Okay, so basically Chipstack have a multi-tenant option, so you can create multiple organizations if you want. Then you can create users, and you can give whether the user is admin or whether it's an active user. You can control all these permission levels. Okay, then you can create global API keys. Okay, in order to forward the data or query the data to some third-party applications, or use the API of the Chipstack. Okay, so now this is the organization dashboard. This is the overall dashboard. This is for organizational users. This is organizational API keys. Okay, so only the users or the devices within that organization can able to use this API keys. Outside the organization cannot able to use. Okay, so then we need to create a service profile. So service profile is something which connects the organization with the network server. In our case, our organization here is a Chipstack, which is a default organization. So in order to connect this Chipstack organization with the network server, we need to create a service profile. So the service profile can be Techbeast service profile, Techbeast service. Okay, so the network server is a Techbeast, and the gateway metadata, RSSI, and the SNR value, the geolocation are added to the packet sent to the application server. Okay, we can just enable it, so we get more information. So enable geolocation, the device status, report frequency, it can be anything. Okay, so it totally depend on the device. Okay, so it makes maximum allowed data race is minimum 0, maximum maybe we can set it to 5. Okay. Okay. So private gateways. This is not a private gateway, so I'm not gonna enable this option. Okay. So let me create a service profile. Cool. So I've created a service profile here. So now the next step is I'm going to add a gateway. Okay. So the step is, so let me create a gateway here. So my gateway name is Techbeast LoRa gateway. So it can be any name. Okay, I'm just giving a random name. That's all. So the gateway description. This is an AS923 LoRa gateway. Okay, and the gateway ID is 7076FF, which is this one. Okay, which you just execute this command and you can note down. Okay, so this is the gateway ID we need to use, and the network server is Techbeast, which we just created. Then service profile is Techbeast service. Gateway profile is a Kerlink is a ifemto gateway. So the gateway discovery is enabled. Okay, so maybe as they stated, the gateway will send out periodic ping to test the coverage by other gateways in same network. So in our case, we are just adding one gateway. So whether you enable or disable is not gonna make any change. Okay, anyway, we just added, and you can set the current location of your gateway if you want. Okay, then you can add tags, you can add metadata if you want. Okay, in my case, I'm just gonna leave everything as default and create the gateway. Okay, so I think my name is too big. Contain words, numbers, and dashes. Okay, so just type the link Techbeast gateway, Techbeast gateway, GW. Okay, anything. Okay, let me just create a gateway. I think there should not be any space. Okay, so LoRa gateway 01. Okay, create gateway. So this is my first LoRa gateway. So LoRa gateway 01. This is the gateway ID. As you see here, the last scene is never. Okay, it's showing never. It will take some time. We just ask the configure to check the last scene every 30 seconds. So the LoRa forwarder is sending the data to the our LNS. So this is the IP which we configured in our gateway in my previous step, and you can see the last scene now a few seconds ago. That's so cool, right? So now you can see the gateway ID or altitude. I didn't configure any GPS coordinates. Okay, so it doesn't really matter. Okay, so you can configure accordingly. And you can see the frames being received. Okay, so the transmitted and receiving frames you can see here. Okay, so then when you click live LoRa frames, so you can see the all the incoming live LoRa frames in your gateway. Okay, that's a goal, right? So this is how you can configure and manage any LoRa gateways via this open source Chipstack's application server. Okay, so now I'm going to show you how to add a device. Okay, so now we have added the gateway, and now how we are going to add a device, I mean a sensor. Okay, so now I have a motion sensor with me now. Okay, so in order to add a sensor, you just need to create an application profile first. Okay, so just create an application profile with the name Techbeast app, and application description is this is an application profile. Okay, then you can select the profile. The service profile is a Techbeast service, and you can create an application. So inside this application you can add your sensors. Okay, so I'm going to add my motion sensor here. I have my device. So how LoRa works is basically as I explained before. So the devices can be either OTA based or ABP based. So this is totally based on how the device is going to communicate with the network server. Okay, so ABP is the activation by personalization, and OTA is over the air activation. So the sensors can be anything, but mostly nowadays the sensors are configured in OTA mode. Okay, so before I add a sensor, I want to create a device profile just similar to the gateway profile. So device profile is your sensor can be any, it can use any network server, sorry, the LoRaWAN Mac version, it can be anything. So you just need to configure accordingly. So in my case, this is the profile I'm creating for my motion sensor. Okay, and the network server is going to be Techbeast, and the Mac version, my sensor, the current sensor I have, supports is 1.0.3. So you need to, when you buy a sensor, you need to verify which Mac version your sensor supports. It can all these information can be obtained from the data sheet. Okay, so mine is 1.0.3. The regional parameter is A for me. The ADR can be a default ADR algorithm. The maximum EARP supported by the device, it can be, I think I can leave it as 0. It doesn't matter. And the uplink interval, it can be anything. Maybe I just choose 5 seconds. Every 5 seconds I assume it's send device. If you know exactly the value, you can just configure accordingly. So the dev sensor sends every 5 seconds. So I just keep 5. Then by default, if you did not enable this, the sensor is configured as a ABP device, OTA. The device supports OTA. Okay, I need to enable. This is a class A device and not class B, class C. So you know we in my previous video we have explained what is class B and class C. Okay, so you can check it out. So the codec is basically we can just use a custom JavaScript codec function. If you are editing something, you can edit how you are decoding and encoding the data. Okay, so in my case I'm just gonna leave everything as a default one, so I'm not going to give any codec. I'm just going to show you exactly what data packets is coming to the LoRa network server. Okay, so let me create a device profile. That's cool for the motion sensor. Now I'm going to my application and I'm gonna create a sensor. Okay, so the device name here is okay, so the device name here is it's a motion sensor. It's a motion sensor 01. Okay, and the device description is this is a motion sensor. Just type whatever you want. Okay, so the device UI something we need to know, and the device profile we can choose the motions as a motion sensor. So you can disable frame counter validation. Your device is disabled, you can check the box accordingly, but I'm not gonna do anything. Okay, so I'm just going to create the device. Okay, so I think dashes. Okay, so let me just add a dash. Okay, so let me create a device. The device has been created, and this is the most complex, I mean the tricky part, the application key. So you should not share with anyone this application key as long as you trust someone. So because your device can be anyone can easily manipulate the device in any LoRa network server. Okay, so just make sure it's this is the security for your device. Okay, so I'm gonna add this application key. Okay, I added my application key, so I just don't want to reveal it, so I just closed it. And okay, so let me just set the device keys. Okay, that's so cool. Okay, so now you can see the last scene is never. Okay, so now if I just trigger my sensor by turning on and turning off, you can see the device data and you can check the LoRaWAN frames. Okay, so let's just wait for a while. The device first will send a join request. Okay, then your network server will accept the join request. Okay, so meaning your sensor and your network server started the handshake and it's now communicating. Okay, when you just click the device data, you can see all the device logs and the uplink messages your sensors are sending. Okay, so now we just need to wait, okay, for a while. Your sensor sends every few minutes and few seconds how it is configured. Okay, so that's it. So that's how the LoRaWAN works. Okay, so you can now we already know how to add a gateway, how to add a sensor device. Similarly, you can buy. There are a lot of cheap LoRaWAN sensors. You can just buy. You can onboard it to this open source LoRaWAN, LoRa network server. Okay, Chirpstack, you can set up your own and you can do everything end to end. Okay, so here you see we received an uplink, so you can see some data being coming inside. Okay, okay, so that's how this Chipstack and LoRa application server and LoRa network server works. Okay, so one more interesting feature here is the application. There is an option called integration. Okay, so you can integrate this chip stack with any third-party APIs or whatever you want. So here in MQTT, you can forward all the incoming uplinks from your sensors to any MQTT broker, or you can send to any AWS SNS. Normally, just if you have a HTTP endpoint, you can just add. So your the application server will just post the JSON response to this HTTP endpoint. If you have an influx database, you can store it. Even you can integrate with a things board. Okay, so we are not going to cover all these things, so that's not the purpose of this video. The video completely covers how you can able to set up a LoRaWAN gateway, how you can able to set up a LoRaWAN server, how we can add a gateway, how we can add a device, and how we can track its data. Okay, so after this comes the use case of big smart city use cases. You can set up a LoRa network server privately, and you can, or publicly, you can add gateways, multiple sensors, thousands of sensors, and you can create a database and store its data and showcase in dashboards. Okay, so that's how this LoRaWAN works.
So thanks for watching, guys. If you like my videos and channel, please subscribe to it and show your support. So let's learn every day. Let's make technology easy peasy for everyone. I hope everyone is staying safe, and thank you.